G'day. Welcome to the third of my 4 videos in which I demonstrate how to use the product rule in calculus to find the derivatives of these kinds of functions. You can thank one of my subscribers called Chelsea for asking me to do this. So thank you, Chelsea, this is for you and for anyone else who wants to see how it's done. Now I'm going to make some comments about this as well. We normally don't like terms like this, where we have the constant first and a negative sign in front of the x. So using our little rule that 1 minus 6x would equal negative or minus 6x minus 1, by taking a negative 1 out the front as a coefficient, we can make this quite easily, can't we? Minus 6x minus 1 plus 1. Now, if we do this to the power 3 or negative 3, it doesn't really matter. The negative just puts it on the bottom of the fraction. The fact is it's odd. And by taking the cube of all of these, we see that the negative sign is cubed, which means I can replace it all with a simple negative. So this, if I did it with a negative 3, it would still be the same. So if I swap this around, a minus sign appears at the front. So I'm going to actually write this as that. That's nicer. That's better to handle. Now I'm not quite sure whether the authors of the textbook this came from have done that and whether their answer will have it in this order, but I'm trusting that they have. Let's go ahead now that we've done this little bit of a tidy up, this little adjustment. Let's now find the derivative. First of all, we notice we have a product, and the second thing we notice is we have a chain in the second. We have a power or a function of a function. So let's deal with the product first. Because we have two parts to this expression, this equation, or this expression rather, because we have two parts, we're going to have two bits to our product. We're going to find the derivative of this and leave this alone. And then we're going to leave this alone. And notice what I did is I left the plus sign and I actually wrote this as negative x squared. And then we're going to find the derivative of that here. So there it is. Derivative of this times this. And then for the next bracket we leave that alone and find the derivative of the second part. So let's find the derivatives now. We've got the structure in for the product rule. Let's look at the chains. Well, this isn't really a chain, but it's actually quite simple. What's the derivative of minus or negative x squared? It is that. I could put it in parentheses. Oh, let's do it. Doesn't really matter. For the second one, what's the derivative of this? Well, it's a chain, isn't it? We have a function of a function. The derivative of this means the negative 3 comes down and we write 6x minus 1 to the power, and we reduce this by 1, which means we take 1 away. And if that goes down by 1, we're down to negative 4. Don't get confused. Times the derivative of what's inside, and the derivative of 6x minus 1 is just 6. That's nice and easy. But just remember, when the negative 3 comes down, drop this by 1, becomes negative 4. Now we have this expression plus another one, and we look for common factors. Well, what have we got common? I could say there's a negative sign in common, but there are 2 here, so I might leave that for a bit and see what happens. There's a 2 here and a 3, there's a 6 here, so I can take 2 out as a common factor. So let's write that down. There's an x here, but there's no there's an x squared, so I can take an x out, can't I? And then I've got this expression, which dominates everything, doesn't it? And you can see I have powers of them, and I'm going to take out the lowest power. Now we're very used to doing it when they're positives, but which is the lowest power between these two? Well, negative 4 is lower, so we're going to take it out. Let's see what we get. What's left here? We've taken out 2x. We're left with a negative sign. And this we've taken out of that. Now, if I divide this by this, it means I subtract the indices. What is negative 3 minus negative 4? Is negative 3 plus 4, which is 1. And you can see that if we check out. We have a negative and the 2x, and this times this, when we multiply, we add the indices, and negative 4 plus 1 is negative 3. So it does work. Plus, let's deal with this. We haven't taken a negative sign out, but we've got a negative times a negative, so I'll leave the positive. If I took the 2 out of the 6, I'm left with 3 times 3 is 9. If I took the x out of the x squared, I'm left with an x. And if I take that out of that, they're exactly identical, same power, so that's been taken entirely out. So that's all we're left with. You can check that quickly. 2x times 9x is plus 18x squared, isn't it? What have we got? We've got plus, minus is plus, 3 6s are 18x squared, and then this other term. Okay. 2x. I'm going to leave this here for the moment. We'll discuss that on the next line. Now let's expand this. Minus 6x. Minus, plus 1. So we've got 2x. This is going to be simpler than that, because here we've got 9x taken by 6x is 3x plus 1. And this one is all that's left. We've got our 2x here, we've got this expression is simplified to that. We can write that here as 6x minus 1 to the power negative 4, or which I'll write. Or we could, I'm afraid we're running out of board here, I would like to go down, but we could write it as 2x times 3x plus 1. And because it's a negative index, that means it shifts down 6x minus 1 to the power plus 4. And either of those would be a good way of writing the result. Both very acceptable. This I would probably prefer if I was substituting x values to see what the expression was worth. I would like to leave it like that if I had to find another derivative or do some other sort of manipulation with it. So it's really a matter of preference and depends a little bit on what you want to do afterwards. But there it is. That's that particular function dealt with. Let's look at another one. Well, this one is very, very similar to the one we just did, so let's speed up a little bit. I'm going to simplify because I like to have the 2x first. Now if I reverse this, I get a negative sign come out, but it's to the power negative 4. Now 4 is even, so it means I'm going to get 4 negative signs, positive. So that and that are the same value. Let's do the derivative. 2 parts, that times this, and then this times the derivative of that. What's the derivative of 3 of x cubed? It's going to be 3x squared. So we've got that derivative times this. Now we've got this times this derivative. This is a chain. We've got a function of a function. What's the derivative of this? It's negative 4, 2x minus 1 to the power, reduce this by 1, negative 5. Remember that negative numbers keep going down. And then we must multiply by the derivative of what's inside, which is 2. I know I did that rather rapidly. Let's rehearse this. Probably should put that in parentheses, because it's got a negative sign with it. So when we do the chain rule here, the negative 4 comes down, leave this alone and reduce that by 1. So there it is. Multiply by the derivative of what's inside. Again, that's my method of doing the chain rule, and I invite you to go and watch that video if you'd like to see how to do it without using substitution. Now, again, we've got these two expressions. By the way, I don't normally underline them in books when I'm doing them myself, but if a lot of my students do so because it helps them, it's entirely up to you. Let's have a look. There's a 3 here, and I've got a 4 here and a 2, or a negative 4 and 2, no common factor, so we'll leave them alone. Got an x squared here and an x cubed there. I can certainly take something out. I look for the smaller power, which is 2, so let's take out x squared. Looking at this, we've definitely got powers of 2x minus 1, and I look for the smallest power, the smallest power, which is this one. Remembering that negative 5 is smaller or lower than negative 4. Well, that's all we got out as common factors this time. Let's see what we got left. I'll just set the structure up. What have we got? Well, in this first one, we've taken out the x squared. We haven't taken out the 3. And these aren't exactly the same. Now, if I divide that by that, I subtract these and I get 2x minus 1 to the power 1, if you like. And you can see that multiplying them and adding those indices gives negative 4. Now let's take these out of the second term. First of all, I've got a negative 4 times 2 is negative 8. So let's deal with those constants. X squared out of x cubed leaves x. So x squared times x gives x cubed. And these are identical. They're both to the power negative 5, so the whole thing has been taken out. So we're left with x squared, 2x minus 1 to the negative 5. And what have we got here? We have 3 times 2x is 6x, 3 times negative 1, and plus negative 8 is negative 8x. Now, this is going to be even simpler, or a lower degree, than x squared, so I'm going to write this at the front. 6x minus 8x is minus 2x. And you can see that we have a common factor of negative 1 there, so I would take that out. Leave the x squared. And then we have a choice. Because this is a negative index, you could still leave it here, 2x minus 1 to the power negative 5, or you could write it underneath as 2x minus 1 to the power 5, because that's all the negative index does, is it moves things up and down inside fractions. Because I'm running out at the end of the board, I'm going to write it that way, and I hope that's helped. But that's, what have we done now? 6, 7, that's 8 done. This is our third video. One more in this video. We'll see what it, I haven't looked ahead, so we'll see what it entails. Let's have a look. Well, this one involves a radical, or a surd. So let's have a little look. Our first job before we get started will be to write this as a power of a half. That's what a square root is. So you can see your index rules are very important. They're vital here. Now the second thing is, I'm not fond of having this last, but when we're dealing with radicals, it becomes a bit problematic doing our little trick of reversing and taking out a negative sign, because what would appear at the front would be a minus 1 to the power of a half, which is the square root of negative 1. And we'll just leave that alone. That's somewhere we don't want to go at this point in time. So we'll leave this alone. If if you didn't understand what I just said, don't worry too much. We'll just find the derivative. So here it is. This is a nice straightforward little expression here, but this one involves a function of a function. So we're going to do a chain again. Being a product of two things, we're going to have two parts. This time, the derivative of that times this, and then this times the derivative of that. So I've left gaps for what I need. Let's put in the derivatives. Derivative of x cubed is 3x squared. Now the derivative of this, we're free now to concentrate here on the chain rule because the product rule's been taken care of. We don't have to worry about whether we left anything out at all. So let's do the chain rule. The chain means we have to deal with this outside function first. Power of a half means we get the half down the front, then the 1 minus 5x, and we subtract 1. Remember that the power must reduce by 1. Well, a half minus 1 is minus a half. So we're obviously playing games of fractions here. But that deals with that. All that's left now is to multiply by the derivative of what's inside. And the derivative of 1 minus 5x is negative 5. Okay. What have we got in common? There's our plus sign. What have we got in common between this expression and this one that we can take out? Well, we have a coefficient of 3 and all we've got here is a 5 and a half, or a negative 5 and a half. Nothing common there. X squared, we have an x cubed. The lowest power is 2, so we'll take out x squared. And we've got this expression and this one, and we use the lowest power. Now what's the lowest between these two? Negative a half. Let's see what's left. If I take x squared out, I'm left with the 3. So there's our 3x squared. And if I divide this into that, I'm going to subtract indices. Now, a half minus a half is 1. So the nice thing is, even when you've got radicals, often over here you've got nice complete terms with powers of 1. If I wrote a 1 here, you can check that out. That times that, add the indices, 1 and negative a half, add up to a half. Put our plus down. Let's see what we've got. First of all, we've got negative 5 times a half. I'm going to write that as negative 5 halves. X squared dividing into x cubed leaves x. I think you can see that x squared times x is x cubed. Or another way is, if you're dividing this into this, you subtract the indices. 3 minus 2 is 1. And this is identical with that, so it's come out totally. That's all that's left. So what are we left with? X squared, 1 minus 5x to the negative a half. And here, I notice I've got a half that I can't eradicate. So I'm going to take it out the front. And that means I'll probably try to do 2 steps at once here. I'll change colours a little bit to show what I'm doing. If I put a half out the front, there are a few ways of explaining this. I'm probably being a bit mean on you. If I put a half here, then I can double these. Because a half times 2 is 1. And that would mean the 2 would divide this 2 out and just leave a negative 5x. So by taking the half out, I'm just leaving the negative 5x. But here it means I'm going to get 6 times 1 minus 5x. 6 times 1 is 6, and 6 times negative 5 is negative 30x. Plus minus is minus 5x. I hope that wasn't... I'm running out of board, so I decided to do a couple of steps at once. I grew up in an age where we did fractions a great deal, so I find it very comfortable. Now what are we left with? We're left with a half x squared. This here, if I add them together, is going to be minus 35x plus 6. And I'm going to write this at the end because it's the worst part. And the convention is we like to leave that at the end. Now, if we really wanted to tidy that up, there are a few steps I would do. I would take the negative sign out of this and put it at the front. I'll leave the half on the 2 on the bottom. So let's write this with the 2 on the bottom, the negative sign out the front, and because that's simpler than this, it's a lower power at least, this will be 35x minus 6, negative 35, there it is, and minus 6 is plus 6, and I'd leave the x squared over here. So half is like dividing everything by 2, and that's that expression. And this, I could either leave on the top like that, or since I've already got something on the bottom, that negative sign will move everything down, and I'll be left with 1 minus 5x to the half, or if I preferred, square root 1 minus 5x on the bottom. And that's how you handle them when you have radicals. Well, there it is. That's the third bracket of 3 questions. A little bit more chewy, this one, but I hope that's helped, and I hope I didn't confuse you too much by taking the half out the front as I was simplifying. Thank you very much for watching. Please leave your comment, like the video, and subscribe if you're not already a subscriber. And if you have enjoyed it, be grateful to Chelsea for asking for these videos. Thank you, Chelsea.